to episode 5 of the CAD Dimensions 3D Printing podcast. We have a number of amazing guests on today's episode, including our newest 3D printer. We have the MakerBot method, which is behind me right there. A little more? Okay, yeah, the MakerBot method right here. And this is a pre-release unit that was given to us that we unboxed earlier this week. Hopefully you should see a video coming out about that very shortly. Would all of you like to introduce yourselves?
Yeah, I'm Kevin. I'm the marketing manager, and I've actually got questions for you about the MakerBot, so we'll come back to that.
Okay, awesome.
I'm Fred. I'm a SolidWorks support engineer.
And I'm Ken, application engineer with the 3D printing team.
And I didn't introduce myself yet, but my name's Adam, and I'm also an engineer on the 3D printing team. So we have 4 stories that we all kind of collectively picked today. 2 of them are kind of on the fun side. 2 of them are more on the 3D printing nerdy technical side. And then we can talk about the MakerBot method, or do we want to start out with that? Let's start out with that.
Okay, well, I just had a question because
Sure.
I hadn't seen the unboxing video. I wasn't here when you guys were doing this. I had the day off, so I'm just kind of curious. I walked by it, and it feels like an air hockey table.
On top?
Like almost like this air. So is that like an exhaust vent up there, or
There's heat vent.
There are fans in the back, like at the back. If you look at the machine, they're back there. And then the top is kind of a grid, and so it would help evacuate
dissipate air,
heat from the motion system at the top of the printer. Yeah.
Cool. Okay. I just wanted to make sure that it wasn't like, hey, this thing's leaking air.
You're not just imagining it.
No, it's cool. It's cool that it's very compact. When we saw the kind of pre-release materials and they were talking about it, I thought it was a bigger unit, and it packs an awful lot into a small machine.
Yeah, it was definitely a little smaller than I thought it would be.
Yeah.
But it looks nice and sleek.
Yeah.
The touchscreen is super responsive.
The UI is really nice.
Yeah.
Good.
Sometimes when you're dealing with touch screens, especially on like cheap 3D printers to control them, like you need a stylus or you just need to like poke at it really, really hard.
Yeah.
But this one's really nice. I like this one. So,
what's your favorite thing about it?
I love that when you run a print off of a USB drive, it loads so much faster than the old MakerBots. If I had a bunch of junk on my USB drive, it would take forever to read it. Like it read the whole card. And
As opposed to just printable files?
Then it let me pick my job. And so once I pick my job, it says, it loads it into the machine, and then it says you can remove your USB drive. So it doesn't have to constantly stream it from the USB drive. Again, which is new compared to the older MakerBot printers. That way you can still use it, and you don't have to leave it plugged into the machine for 10, 12 hours, depending on how long your print was. So that's definitely, it's a little thing, but from a user standpoint, it's a huge improvement.
Nice.
So
very cool. Ken, what is your favorite thing?
I like the bed.
The bed?
The bed's really cool.
The spring steel beds are becoming more popular on machines now, and they got one. It's got a nice like rubber coating around the side, and it's reusable, which is really nice. So you just take the part out. The part itself pops off of the PVA raft, and then you just lightly scrape the raft off. It comes off pretty easy, and then toss it back in. It's good to go.
Nice.
There's no more blue tape.
Yeah, pretty quick process to do that then. Nice.
Yeah, the flexible beds are definitely very helpful.
Nice.
Ben, I'm sure you can just throw some B-roll in there of us working with the really cool new MakerBot bed, because I know we talked about it in the unboxing video. I'm sure we have.
You can't do a B-roll in the podcast.
Why not?
It's not high production.
Let's cut to the tape, folks.
Cut to expensive stock footage of a bald eagle attacking a duck. Which leads us beautifully into our first story to talk about. So Fred found a really fun story about a 3D printed rubber duck project. Do you want to tell us a little bit about it?
Yeah, so I guess they're trying, one of the maker fairs, I can't remember what city it was, one of the maker fairs is trying to break the world record of the largest 3D printed duck, which they're estimating will be about 6 feet tall. And I guess anybody can be a part of it. There's 476 pieces. I believe they'll send you the piece. You just have to 3D print it and send it in. You can be part of the, Guinness Book of World Records there. To break the world record of the largest 3D printed duck, which, pretty big and cool.
Yeah, I think it was a Maker Faire coming up mid to end of April, and it's in Connecticut.
I think
which
something
means
like that.
it's close enough that
could
we
maybe check it
could
out.
go there.
Yeah.
We should do it.
And we have 3D printers, so we could totally participate in
yeah.
this.
We could print
If we could print it on the new MakerBot
6 at a time.
because it has super cheap material.
Yeah.
And we could print
Can we-
a part of the world's biggest 3D printed duck.
Can we put the CAD Dimensions logo on it or something? Do you think, are we allowed to modify it at all? Is
don't
it
think
just
so.
a?
I don't think so. So what they do is
yeah, you're allowed to pick your own color. That's kind of the thing.
Okay.
So you get a portion of the duck. So they cut the duck up. It sounds terrible. They cut the duck up.
It's a puzzle, basically.
basically,
Yeah,
yeah.
it's a 3D
So what they do
puzzle.
is everyone gets a piece of the duck. They can choose any color they want, but they send them the file to print. I choose any color filament, any kind of filament I want. Print my part and send it in, and then they number the pieces so that when they're putting it together, it's easier to put together. Then the day of or the event, they get all the pieces together, stack them all up in the order, and you have a big multicolored giant duck. It's not always a duck, but
yeah,
giant
yeah.
duck.
Yeah.
See, I want to be able to like pick where on the duck my part went to. You know, I'm like, hey, I want to get like, I want to be prominent on the beak, or
Yeah.
you know, let's look for like middle tail feather number 2. Not like here's a square on the bottom. You know, somebody's got to fill that
You can
spot.
put in your requests. I don't know if they'll.
Someone's got to take the non-glamorous
Right,
parts of the
right,
duck.
right.
Okay, it's a team effort. But I've actually seen it's essentially like crowdsourced sculpture.
Yeah.
If you think about it in that
Yeah,
way.
that's a good way to put it.
Where I've seen it done with like busts of Einstein and a couple other things that I don't know. There's a couple groups that do them at maker fairs, and it's kind of a cool community collaborative event, exhibit
I
type
think
of thing.
the one I saw last year was a giant Rosie the Riveter, and they specifically asked for all women that
That's
use 3D
cool.
printers to submit parts.
Do you know, will the duck be buoyant? Is it going to go in like, will it go in, I know, of course they do a lot of local communities do like a duck race where they drop like hundreds and hundreds of rubber ducks in a river and then they float and watch it, you know, see where they end up. Is it going to participate in something like that?
I have no idea. There wasn't too many details on it.
Is the duck also like a canoe that you can like get in and like
Oh, that would be
row
cool.
yourself? That would be way cooler.
I would
be
imagine
cool.
it would float regardless. But
Right, as long as
do you think
They'll
the
probably float for a little bit until
Yeah.
the 3D printed parts start taking in water because
Yep.
they can.
Yeah.
So your duck will slowly start to sink.
I think we
That's
should
fine.
keep the duck safe
Yes,
on dry land.
dry land.
Yeah.
After, all 600 plus people have
Submitted.
put in the effort.
It's better served as an art installation
Yeah.
than a
Yeah.
utility duck.
Yes, utility duck.
dry duck?
Just utility duck.
I like that.
Okay.
If your printer breaks, can you just use a part of a real duck?
No.
No.
If your printer-
No, you can't, man.
you can find a
my
duck that
3D printed part. Here's part 212 and 3 feathers that I found.
that I
Make this
found
happen.
down by the river. Maybe you'd get an honorable mention for just, creativity or something.
Sure.
Yeah.
Contribution.
I ran out of material, but here's a foot.
It would be a pity. It'd be like a throwaway, like, oh, bless his heart, he wants to contribute.
Yeah. It is a team effort. Anyway, where do we want to go next? We have 2 stories that are both kind of revolving around metal 3D printing.
First, I insist.
I don't
you wanna hear
know.
me first?
I want you to go first.
Okay.
Mine'll be next, and then
Okay.
we can finish up with
Sure.
Ben's story.
So the article I found was it 3D printing industry? One of those 2 main websites. It was a collaboration that was announced between. Now I just forgot the name again. What was the company?
Wow, I'm sorry for putting you on the spot. It was Aurora.
Aurora Labs. That was it.
Aurora
Aurora Labs, University of Western Australia, and the Royal Perth Hospital. So obviously all taking part in Western Australia area. And the goal of the project is for Aurora Labs to create 3D printed titanium implants for humans in collaboration with the university, and then qualifying these for surgery through the hospital program. So this is something that is already in existence. There's already places working on it, but this is kind of a cool situation where you have a printer manufacturer teaming up with a university and a hospital to get qualified.
So hospitals now are using titanium parts in people, and they're using that for surgical replacement parts, I'm assuming, and
I don't know
Hip
for sure
joints
if they're
and-
using it. I know that I've seen plenty printed. I don't know if they're still in a qualification phase.
Mm-hmm.
But I do know that I've seen metal 3D printed components with the intention of become implants.
Yeah, I've seen like pictures of hip replacements
Hip
and that sort of
replacements,
thing.
yeah.
Yeah.
well, then it only makes sense that you kind of cut out the middleman and go directly to the company that can make it
Yeah, and
easily.
the thing, and we've talked about it previously, the thing that's great about 3D printing and, of course, metal 3D printing, customability. Because everyone's a different size, everyone's got slightly different dimensions and what else.
Were you about to say everyone has slightly different geometry?
It was close. But everyone's different. So, like, if you're working with a kid, an adult, man, woman, it's all going to be different. So every part can be printed specifically for that person. So that's obviously something that it's not the cookie cutter product that was available before.
That's pretty neat.
Yeah. I think it's notable that the manufacturer is, I'm assuming, help pay for this qualification process, because getting something approved for medical use is very long and very expensive process. Not that I'm an expert in that in any way, but just from what I know about it.
Think about it. It could be very profitable for the company, too. If they can become the qualified source of implant components, because I'm sure there's not only qualifying the parts, but qualifying the actual printers themselves for repeatability, reliability. But it could be profitable for them as well. So we'll see.
Let me ask an ignorant question, because what piqued my interest was titanium metal parts.
Yes.
And I guess when we think about metal parts, I think of stainless steel or things like that. In terms of like a metallurgical standpoint, is there a bigger challenge that comes in printing something in titanium, or as far as like using our desktop metal printer, is it irrelevant to the printer what the feeder material is in large part, as long as it's metal? I'm just kind of curious. I mean, is it more of a tough science to work out titanium versus stainless steel? Or?
There's different properties within metal. The biggest one being temperature. So at what temperature does it become pliable enough to print with?
Sure.
Titanium is solely done right now on laser-based systems. That's all I know of. I know the big one I always hear about is aluminum being too gummy. Like the properties when it becomes not a liquid, but a
close to liquid.
Close to liquid state becomes too gummy, and that's why it's very challenging to print, especially with the FDM process.
Yeah.
Stainless is a little bit easier.
Stainless and titanium are both pretty popular material choices in metal 3D printing as a whole. Right. I know Desktop Metal has done some experiments with it. Hopefully we'll see it at some point, but I mean, again, not a metallurgist, but from just being close to metal 3D printing technologies, stainless steels and titanium sinter similarly, or at similar rates or what have you. And so they've both been done successfully.
I think if you look at Desktop Metal in particular, they've focused specific materials based on what their customers want.
Sure, that makes sense.
What's
the demand in the market?
Their focus has been on stainless steel, tool steel, copper, Inconel, those kind of materials.
Right.
For replacing added or manufactured parts and.
Sure. Yeah. Whereas if you look at Aurora Labs, titanium is great because it's been used in medical devices before, and it's super strong. It's lightweight. It's been known to be accepted in the body, not rejected in surgical complications.
Sure.
And so for them, titanium would be naturally a really good choice. So, yeah.
Very cool.
Yeah, I think from here we'll move on to the story that I picked. It might be the best story, it might not, but it was something I was excited about. It ties right into that whole metal 3D printing materials. When I was looking for stories, I swear half of them were all about metal 3D printing, which I know is something we've said before, but it's really big right now. So this was a story about the company 3DEO, the number 3DEO. They say it 3DO. I don't know. It sounds weird when I say it.
Like it doesn't need an E?
Like it doesn't need an E?
Yeah.
Or like it needs a hyphen?
Yeah.
I don't know. It feels weird to me. But anyway, so they are a metal 3D printing services company out of LA.
Okay.
And what was interesting to me was the article was talking about them doubling their production in the first quarter of this year. But what's super interesting is that they don't use other people's technologies like a lot of other 3D printing services. They have their own proprietary metal 3D printing technology that's different than anything that I've seen before. They call it selective inhibitive sintering compared to selective laser sintering. So essentially what they do is it's a powder bed process, uses metal injection molding powder, and draws the outlines of shapes. Essentially, if you think of like an eggshell.
Like a shell, yeah.
So if the model you want to print is inside the egg, that's the good stuff. They would print the shell, and then they would kind of blow off the excess metal powder, and then sinter them. And the shell of the egg, in this case, prevents the metal powder that's kind of clumped on the outside from sintering to each other. So that just turns to powder, and then you can kind of break your model out from the inside. And the pictures that they choose, especially compared to binder jet metal printing, look really, really impressive.
I saw the video, yeah.
Did you?
When they were measuring the final parts, and it looked really sharp. They looked like nice finished parts.
Yeah. Anyway, I thought the technology was important. I thought that it was interesting that they've seen enough sales last year to justify doubling their production.
Well, the important thing to add is they're only a year old.
Are they really?
Yeah. So
Okay, I
they
didn't catch
started
that.
last year. They're doubling their production in the second year of existence. So obviously there's demand.
I think, yeah. I mean, metal 3D printing is probably going to dominate this conversation for the next foreseeable future, just because I
At
think
least
that
this year, yeah.
so many applications are great fits for that type of process. So that reminded me of a conversation I was having the other day with one of the SolidWorks technical territory managers who was mentioning how important it is for companies to begin the design and simulation process with the intent of producing an additive part. What is that process different? How is that process different if you know that you're designing for additive versus subtractive? Like, what are the 2 or 3 key things that really change that process? And this is not necessarily for Fred, but anybody.
I don't know, really. It's a lot. When it comes to using simulation or anything like that, where you're trying to represent the stress of anything, it's a good way to kind of prevent yourself from making about 1 million prototypes and then going back and saying, 90% of these didn't work, they failed.
Right.
So it's really just getting that step ahead. Between the difference between like additive and then like subtractive manufacturing is probably not a huge amount of difference, to be honest. But I mean,
What do you
you
think,
may know
Ken?
something. One of you guys might know something better than me, because I'm just the SolidWorks guy.
I'm not trying to start a fight here, but it's much different.
Yes,
Is that-
it is very
Way
different.
different.
Okay.
Depending on
You're gonna teach me.
how you produce them, parts that come off like the desktop metal system would be close because they're fairly isotropic in nature. Parts that come off all these systems, the FDM systems, well, polyjet would be different too, but off the FDM systems, they're layered. So the weakness is actually the layer adhesion.
Yeah.
So it doesn't act equally in all directions. So it's been a very big challenge for companies to create simulation software that includes the factor of delamination of layer lines. I was expecting you to talk about topology optimization, because that's one of the big ones that usually they can't do in the CNC world or traditional manufacturing
Right.
methods.
Yeah.
We were thinking about topics, and when I was looking for topics, I considered just saying topology optimization is the topic of the podcast, because I think it's really, really cool.
Yeah.
And I think as especially more metal technologies, similar to the desktop metal production system or what 3DO, it's never going to stop sounding weird to me, similar to what they're
3DO.
doing, really unlocks the capability of topology optimization and making the perfect part for the perfect application instead of just what you're able to machine.
And so for anybody who is not familiar with topology optimization, that's basically where if you have a truss that looks, in a certain shape with cross sections in a certain orientation, SolidWorks will take that part file and say, well, in reality, you don't need this here. You don't need this here. And it'll help you streamline your part so that you're using less material, less resources. It may sometimes look a little unorthodox because those shapes are not how a designer might express his intent, but that's how the system comes back with here's the best.
It's a little confusing to the naked eye because you don't see things made that way.
Right.
So like you look
You
at
don't
it,
see
you
that
don't
in
think-
nature.
You don't see it in nature. Well, a little bit, but you don't see it traditionally manufactured. So you're like, oh, it should look like a block. It should look so much bigger.
You want
and
clean
heavier.
shapes and edges and
Where
corners.
this looks very, I don't know, very.
It usually looks something more like you would find in nature
Right. Oh,
than
true.
you would coming out of a machine
because
shop.
it's more amorphous, right?
Yeah, it looks. They're all more organic shapes that kind of looks like things you would find on an alien planet, much more than coming out of a wood shop.
Yeah.
Okay.
But they're cool and they're optimized.
Yeah.
And
We could do a whole episode on
we
topology
could.
optimization.
We could,
Down the
and
road.
maybe we will. But regardless, I think we're at a good point to talk about our very last story. And this is all about the Hexbot Kickstarter. And so I know Ken and I have some strong opinions about Kickstarters, having been burned on a couple in the past. And in particular, Kickstarters are, kind of as a background for you guys, Kickstarters in the 3D printing community
started a lot of companies.
Well, they've started some companies.
True.
And they've also led a lot of companies to failure.
Yes.
And so they're kind of a sore subject. But there's a company called Hexbot that, as of recording this podcast, has raised over $600,000 to bring their little robotic arm project to life. And I'm sure, according to them, that's not doing it justice. But essentially, it's a little robotic arm, and you can use it for a pick and place. You can put a Sharpie on it and have it draw pictures. There's a 3D printing option. There might be a CNC option.
Probably a laser in there somewhere.
Yeah, I think there's a
there was
laser
a
engraver.
laser, CNC, there was a foam cutter, there was about 1 trillion different heads and attachments, and super cool.
Yeah. It seems really cool. What are your other thoughts on it? Would you buy one?
I would.
Would you have a need for one?
So I've thought about this because as I mill about my house and try to solve common everyday problems, I find myself now thinking, I wonder if I could 3D print something to fix that. So I think that I would absolutely look into buying one. A, because it's neat, and B, just because of the versatility. Like, I don't have a machine shop. I don't have a great need for that kind of thing. But to be able to have that freedom of flexibility and change things out in a mountable desktop unit that stays in one place, and it's a safe robot that you don't have to worry about collisions and interacting with people. It's a dumbed down version. I would be more intimidated by the software than anything else, I think.
Yeah.
The question I'm going to ask, and this is the question that comes with just being on Kickstarter. Are you willing to invest in that project?
Well,
not buy the project, invest in the project.
Well, so because you're talking about two different things. Because the robot arm and the rotating heads, the change-out heads are the physical part of it, but the software has got to be really a challenging
Complicated,
thing, right?
Complicated to create as a programmer, because if you have all these different options, in some way you got to be able to identify those, program them differently.
Robotic programming is
calibrate
not easy.
them.
Yeah, and they had a couple of screenshots of somebody utilizing it from the app, and it's like, oh, X, Y, Z, easy enough. And, Jane Doe on the phone makes it look like it's no problem. But I'm like, I think in reality it's a little tougher.
It always looks easier on the internet.
Doesn't it?
Right?
Yeah.
On the note of versatility, one of the biggest things I hate about Kickstarters who promise versatility, especially in the 3D printing space. There's been so many Kickstarters who are like, snap on a laser engraver, snap on a 3D printer, snap on a marker, slap on a vinyl cutter. Do you want one machine that does everything kind of okay? Or do you want the right tool for the job every time?
So do you see Kickstarter as more gearing itself towards, I mean, obviously it's more geared towards hobbyists, but these are legitimate businesses that are trying to get off the ground. They're probably trying to make their service, their offering, as palatable to as many audiences as possible.
Exactly.
So they've got to include those features to make it a fit for everybody.
From what I've seen, Kickstarters, mostly in 3D printing, but in a lot of different areas, can sometimes become just more marketing experiments than they are legitimate companies trying to get off the ground.
Sure.
In particular, there's a horror story of the Peachy printer within the 3D printing community, where it was a super cheap $99 SLA machine. Everyone was super excited about it, super cheap, cheaper than anything else available at the time. And they raised a few $100,000 and delays, and then at some point, the guy who helped co-found it said, I'm really sorry, I don't know what happened to the money. My partner just built this house, and none of you are getting 3D printers.
Sorry.
There's some bad blood there, especially in the 3D printing community, because there are no guarantees with what you're going to get from a Kickstarter. So naturally, I wish them the best of luck.
It sounds like they're well funded. I mean, it
seems like you could do a lot with $600,000, right?
The challenge with all of these projects, even for the companies that are genuinely good morally, and they're trying to develop and start a company.
Good morally. I like how you throw that in there.
Well, there's been companies that
you're right. Yeah.
That in that case, the guy just goes completely behind the investors. Right. The biggest challenge that you consistently see over and over and over with all of these like machine manufacturers is when they go from a prototype, which they have a working prototype, it works great, it looks awesome, to going to full-scale production, is where they almost all fall on their face. because they try going overseas. They run into the costs of doing it locally or wherever, and then warehousing, shipping, all this stuff they just are not prepared for. They are good at designing, they're good at making the product, but when they run into the full business spectrum, that's when most of them fall flat.
Okay, I've made 3 of these, and I've taken a video with one of them. I gave one to my mom and one to the investors, now I've got 300 orders.
And I've now promised 500 investors them that they're all going to get it this year.
Right.
Well, hard to do.
And you essentially get a ton of money overnight.
Yeah.
And
you've got to go to scale immediately.
To try to hit those deadlines.
Daunting.
So, Kickstarter can be a sore subject in the 3D printing community. I wish them the best of luck. But I think it's really cool.
Yeah,
but do you have a better place where people can go and experiment and try those things out? So I don't know. It's better the devil you know, I guess.
Yeah.
At least there's a place where people can bring those ideas and flesh new things out.
Yeah. For the good companies who have the skill sets to bring products to life, I'm sure it's a good option. Ken, if you had a robot arm, whether it's a Hexbot one or not, what would you do with it?
I don't even know. I'm pretty content with just the printer. I'm sure.
Could you use it?
Can it fold my clothes?
Fold my clothes, yeah. I wouldn't see much use for the pick and place because I'm not a factory.
Yeah.
I'd probably just enjoy picking things up and putting them down just for fun.
It'd be cool to show everybody.
Yeah, like I've tried to make little robot arms at home.
Cool.
Laser engraver I might use. CNC I might use. But of course, you have to use soft materials. You have to use woods and maybe an aluminum, but I doubt it.
It didn't look strong enough to do aluminum to me.
I'd say probably wood and foam. That's all you're going to
get. The way that arm was assembled, I don't think it'd be able to put the pressure on it.
Probably vast majority of what I do with it would just be gifts and fun little trinkets, like nothing of super production value.
Yeah. Here, Mom, I put your portrait on a piece of on a plank of wood.
I'm sure your mom would love that. Yes. Would you use it to remove prints from your printer? I would want to.
That'd be cool.
You wouldn't burn your hands.
Burn your hands.
That's reference number 9 this week. Okay.
We learned an important lesson. Things
Just
that come out of a printer are hot.
Think about that. Fred, what would you use it for?
I have no idea.
No idea? So you're telling me that you have no use for a robot arm.
I think I would like.
What kind of engineer are you?
Yeah, it's a terrible one. One with not a lot of free time. I don't know.
I've got a page turner of all the books of the book.
Oh, there you go.
Putting the dishes away.
Is that too hard
folding
for you?
Clothes.
Turning pages?
No, but if I can just lay it back and it can just.
Okay.
I don't know.
Is this something that causes you stress in your life?
Well,
Maybe.
You guys think about it. I would really want it to cook me breakfast.
There you go.
Because I'm not a morning person. And if I could just have the robot kind of wake up automatically, start cooking me some eggs in the morning, that would be a significant change in my life.
Then that could be like
awesome.
step 1 to recreating the kitchen from like Honey, I Shrunk the Kids, where you like wake up and flick a switch and then, without all the track and the Rube Goldberg device.
Yeah, not all that, but just like a nice little robot, some eggs next to it,
If that's what floats your boat, man.
Yeah,
I
absolutely.
think I can get some things to do with it for sure.
Yeah. All right, back to you, Fred.
Oh, back to me.
We're giving you
back
time
to
now
you.
to think about
I
it.
wanted you to think about it.
I would probably just really have fun with laser engraving because I used to do that before in high school and whatnot. I used to laser engrave on everything. When we had woodshop class, they always gave me A's because I would throw it in a laser engraver after I turned things in, and they'd be like, "What did you do?" And I'm like, "They have a laser engraver over there." I would just probably get back into that, get back into woodworking and stuff. It's something I haven't been able to do for years because I just don't have the tools, don't have the space, time, anything like that.
Yeah,
but if
you
I
could do a whole Etsy crowdsource, you could make all sorts of neat stuff.
Yeah.
You could make anything, really. Because if you want to just make little, the one thing I could see I could use it for, which is kind of silly, if I wanted to make wooden paintings that were engraved.
Yeah.
That would be fun to do. I would like that.
Did it have a measurement tool, like a CMM-like tool?
I don't think so.
I feel like it had something like that. Maybe that was another one that was similar.
I think it was just trying to show how precise it is.
Yeah.
That it
Maybe
was
that was
poking.
what it was.
It was poking things with a probe.
Mm-hmm.
Okay, maybe that's what it was, and that's what I mistook it for.
Yeah.
That's more likely.
Yeah. Be cool though.
That is cool.
Anything else you guys want to chat about? Robots or 3D printing or making breakfast?
MakerBot.
Cool. All right. Well, thank you for taking the time to watch episode 5 of the 3D Printing Podcast. If you didn't like this podcast, make sure that we know about it, because we want to make good stuff for you. So make sure to hit the dislike button if you hated it. Or conversely, if you liked it, hit the like button. And we will see you again next month for our 3D printing podcast. Thanks for watching.